Okay, brilliant. Starting on a personal note, it's 50 years ago this year, in the summer of 1974, that I worked as a student mining geologist at Wheelchain Tin Mine in Cornwall. I became interested in the history and prehistory of tin mining. So it's about time then that I came to some conclusions. So, could Bronze Age Britain have been a major source of a pan-European tin trade? It has been widely speculated for over 200 years that the very rich and accessible tin deposits of Cornwall, Devon in southwest Britain could have supplied Bronze Age Europe and the Mediterranean in the mid-second millennium BC. Project Ancient Tin was set up to review in detail the archaeological and geological evidence and undertake a major analytical program on tin ores and tin artifacts to see if the tin provenance of artifacts could be established. Our focus has been on Western and Central European tin sources. Where are the tin sources large enough to potentially supply Bronze Age Europe and the Mediterranean? The tin deposits shown here in yellow are not all equal in terms of the amount of ore present, the richness of the ore, the ease of working in hard rock or soft rock, and accessibility to transport. They range from mineralogical curiosities to those that rank among the largest in the world. This is a very important point. From my mining geology background, I know that some tin mines or deposits have low-grade tin ore and very limited amounts of ore. Others have high-grade ores and very large quantities. So not all mines or deposits are anywhere near equal. In Bronze Age Europe, there are 4 major tin regions. Cornwall, Devon in southwest Britain, by far the largest. Historically, it produced around 2.7 million tons of tin from an estimated 2,000 mines. The German-Czech Erzgebirge region produced about 0.3 million tons, we're talking historically here, and the extensive Iberian tin belt around 0.15 million tons, and the smaller Brittany deposits in France around 0.01 million tons, plus various minor deposits that could have supplied local needs. In the Mediterranean, you can see there is a gap in major tin deposits, and so civilizations in that region had to get their tin from thousands of kilometers away, either in the east or in the west. What is the chronology for the spread of tin bronze, and then the full adoption of tin bronze, bronzitization across Europe? The first sustained use of tin bronze was in the Near East around the start of the 3rd millennium, with the tin coming long distances from the east, based on textual sources. This diagram represents regions as circles and shows the situation before 2200 BC, with the proportions of metalwork that are tin bronzes in orange, and none in Western or Central Europe. Then something remarkable happens around 2100 BC, when Britain and Ireland rapidly changed over all its metalwork to being tin bronze, based almost certainly on the rich tin deposits of Cornwall and Devon. Only in the following centuries do the other European region switch all their metalwork to tin bronze, bronzitization, chronologically later as you move from west to east. How was European Bronze Age tin produced? Was it from hard rock mines on veins mined underground, like many European Bronze Age copper mines? Or was it from soft rock, alluvial deposits in valleys, where heavy insoluble pieces of tin ore eroded from veins were concentrated? No dated Bronze Age tin mines are currently known in Britain or Europe, although some underground tin mines have been discovered in Central Asia and Turkey. It is thought that Bronze Age tin production in Britain was dominated by the much easier to work alluvial tin deposits, although it is possible that some rich veins were exploited in shallow open cast surface workings and possibly on sea cliffs. Alluvial tin, as I said, is derived from the erosion of these primary tin veins that occur in and around the main granite outcrops. And you can see here in red, about 5 big ones in Cornwall. The main tin ore is cassiterite, tin oxide, that can be black, brown, red, and even white, in which very heavy and insoluble in water cassiterite is present. The eroded cassiterite enters the streams, typically as gravel to sand-sized pieces, are concentrated by water over geological time into heavy mineral layers, placers, and are later buried under barren alluvium. And some cassiterite may also have been worked from eroded ore very close to the veins, called alluvial deposits, and possibly limited amounts from beaches and active stream beds. Gold is also present in some Cornish alluvial deposits, and Bronze Age gold prospecting may have led to the discovery of cassiterite, as several people have suggested in the past. So when considering where Bronze Age tin may have been worked, it is the alluvium in the streams draining the tin veins that were more important than the veins themselves, shown in red here. In fact, alluvial tin deposits dominated Cornwall Devon tin production until post-medieval times, when hard rock mining expanded. As can be seen here, streams draining tin veins are widespread across Cornwall and Devon, and most contain alluvial tin ore. We have historical records of many alluvial tin deposits and archaeological evidence for many others, from aerial photography, LiDAR, and field evidence shown on this small inset maps. Hence, across many parts of Cornwall and Devon, we have a widespread tin-rich landscape, probably the richest in Europe, with virtually every valley that drained the main granite outcrops containing buried alluvial tin. One important point to understand is that the depth of the buried tin bed was very variable. It can be from only a couple of meters in some upland headwaters to tens of meters further downstream. The basic technology for working these deposits changed little over the millennium, requiring digging, water washing, crushing, and smelting, although the methods and scale developed over time. Bronze Age tin workings are very difficult to identify because many sites were reworked in later periods. It is probable that at least some alluvial tin and later major hard rock tin vein deposits were worked more or less continuously for nearly 4,000 years in Cornwall, Devon, with production records stretching back to AD 1150. Tin was one of Britain's major exports in the medieval period and had a virtual European monopoly for many years, with a reputation for high purity tin. What is the current archaeological evidence for Bronze Age tin workings in Britain? The classical texts of most interest are all derived from a lost book by Pytheas, who was from the Greek colony of Massalia, modern-day Marseille. Pytheas, or Pythias, in about 320 BC, in the Iron Age, visited Berlurium, which we believe is land end in Cornwall, and described tin workings and how they were mined, and friendly local people, and the bringing of the tin to the tidal island of Ichthus to trade, probably St. Michael's Mount, a tidal mountain in West Cornwall, shown here, and it is adjacent to the mainland's rich tin workings. A spin-off from our tin project was undertaking the first ever archaeological research excavation on this island in May last year, and more excavations are planned. From this island, the tin reached the mouth of the Rhone on the Mediterranean in only 30 days, according to the classical texts. Did this trade date back to the Bronze Age? Jumping to the 18th and 19th centuries AD, There are numerous Bronze Age metalwork finds discovered in alluvial tin stream works that were being reworked in that period, and some of those finds are shown here. Two of these finds in the Royal Cornwall Museum have been recently dated: an antler pick from the Carnan Valley to around 1600 BC, and we recently announced that we have sampled and dated a one-piece wooden shovel also found in the Carnan Valley streamworks to around 1200 BC. Moreover, there have been a whole series of recent Bronze Age tin-related finds from development archaeology, especially with the increased awareness of knowing what to look for regarding cassiterite tin ore and ore crushing tools, which are ore crushing rather than some other purpose. A re-evaluation of the early beaker presence in Cornwall, that is around 2400, 2100 BC, has taken place after the discovery of a structure near Sennen, Land's End, associated with beaker pottery. The stone tool surfaces showed patches high in tin and also microwear consistent with tin ore crushing, and we have identified potential alluvial tin deposits nearby. Several sites have now yielded cassiterite ore buried in pits, such as the Tragura Valley, where around 10 kilos of cassiterite was discovered in pits with early Bronze Age dates. Tin metal finds include those from Whitehorse Hill kist burial on Dartmoor, consisting of a cattle hair band with 32 tin studs and a fusiform tin bead. Then we have the 40 tin ingots from the Bronze Age Salcombe wreck that Thomas mentioned, and the 44 undated ingots from the mouth of the River Bigby Bay that drains Dartmoor. How do we interpret the Cornwall Devon archaeological evidence alongside the geological and historical evidence? Alluvial tin is present, as I've said, in all the streams draining the fine main granites, here in red, and the surrounding rocks. We've plotted over 12,000 Bronze Age archaeological features and looked for any centres associated with each of the granites. We found no evidence of central control, although it is highlighted local clusters of archaeological features that may be related to tin workings, and we will give some examples later. We propose a decentralized production model of alluvial tin workings in which numerous small communities producing tin on a small scale in the slack periods of the agricultural year, and which they took to central Ichthus-type locations on the coast to trade. This contrasts with the Bronze Age copper mining that was often dominated by a single large mine in some regions. So there is an impressive and increasing amount of archaeological evidence of Bronze Age tin working and production in Cornwall and Devon. What about the other European tin deposit regions? Evidence is currently limited, but growing and growing. In the mountainous Erzgebirge region on the German-Czech border, there is a major new EU-funded project underway called ArchaeoTin, involving many scientists from Saxony, Bavaria, and the Czech Republic, looking at prehistoric and historic tin mining. Current Bronze Age evidence consists of dating charcoal from multi-period alluvial tin waste tips from at least two areas, giving early to mid-second millennium dates. We look forward to more results from this exciting project. Detailed research in Iberia, the project Iberian Tin, has done work at various sites and found evidence of prehistoric tin, but the dates so far are all late Bronze Age to Iron Age and later. In Brittany, there is one middle to late Bronze Age date on charcoal associated with tin slag in the Saint Renan area, and Iron Age tin slag from the Cerderet Valley. In the Massif Central at the Feltry mine, charcoal from an alluvial waste tip gave a late Bronze Age date. Our research looked for a way to distinguish Cornwall Devon tin from other major European sources, by analysing tin ores and tin metal with known provenances. If successful, we could determine the most probable European source for tin artifacts, such as ingots on Bronze Age shipwrecks in the Mediterranean. We have used three independent analytical techniques: multi-chemical, multi-element chemical analyses, lead isotopes, and tin isotopes, and we have tackled the long-standing problems of dissolving cassiterite for analysis. Given the low impurity levels in most tin metal artifacts, mainly high-grade cassiterite concentrates suitable for smelting were analysed, typically 60 to 75% tin, rather than low-grade tin ores. Around 200 tin metal artifacts were sampled from all periods, mostly with a clear Cornwall provenance, and also probable shipwrecks, both off the British coast near Salcombe, Bronze Age date, and the or Bigby Bay wreck, possibly Bronze Age or Iron Age, and off the French Mediterranean coast, the Rochelong wreck, dated around 600 BC. And we sampled individual tin artifacts. We also analysed tin roll ingots from the Analoop Mollengat, a Dutch shipwreck that sank in AD 1635. Recovered ingots are stamped with seals that identify the source as from the Erzgebirge region, and so supply us with a reference material. We collected over 360 Cornwall Devon cassiterites and sampled those from many collections, particularly the Box Museum in Plymouth, and from private collections, plus pan samples from 2 months of fieldwork in Cornwall and Devon in the COVID year of 2020. Very quiet it was too. In addition, around 60 ore samples from European tin deposits were sampled, including many from the Mannheim collection gathered from the earlier Bronze Age tin project. Laboratory and field tin smelting experiments were carried out. Using tin ore actually recovered from a Bronze Age site, actually using Bronze Age tin ore from the Tragura Valley in Cornwall. The ore used and the metal produced were analysed to understand the elements that transferred into the metal and any tin isotope fractionation. What are the results telling us? The large amount of data from the multi-element chemical analysis results has been explored using a variety of techniques, and we had an open mind on multi-element predictive modelling for provenancing. And there are several elements of particular interest we could use. However, one element stood out as a strong indicator of provenance by itself, namely indium, an avenue of research suggested by Daniel Berger et al. In 2019. Here you can see on the left in yellow the high indium of most of the Cornwall Devon cassiterites, while the Iberian, Brittany and Massif Central ores we analysed were either below the detection limit or were less than 10 ppm indium. However, the ores from the German Czech Erzgebirge were closer to the Cornwall Devon levels. So how do these indium levels compare to the groups of tin artifacts shown on the right? The Cornwall Devon artifacts, terrestrial ingots, Salcombe shipwrecks match the local ores as expected. Importantly, all the Bronze Age to early Iron Age tin ingots from the Mediterranean shipwrecks analysed to date, Israel, Durham, Rochelong, are consistent with Cornwall Devon ores, but also with the German Czech Erzgebirge ores. Can we further distinguish between Cornwall, Devon and the Erzgebirge ores using lead isotopes that can indicate the geological age of tin ore formation? Well, let's have a look at the lead isotope data. To set the scene, copper ores on the bottom left ellipse usually have their lead isotope ratios fixed when they are formed and plot in a fairly narrow area, but wide enough when greatly expanded from this graph here to allow distinguishing copper sources and are widely discussed in the archaeometallurgical literature. Cassiterite tin ores, on the other hand, are often having radically different high lead isotope ratios because their ratios are not fixed when the mineral is formed, because they often contain radioactive uranium that decays to lead. This changes their lead ratio over millions of years, very often to extremely high levels. And the form, and this changes their lead ratios. And the line is defined that along that decay. And the position of a particular sample depends on the level of uranium in that sample, the initial lead content, and importantly, the slope is governed by the age of the mineral deposit, an isochron. The radiogenic lead produced by uranium decay has a strong effect on the ratios when the initial lead content of the cassiterite ores is low. And in fact, it is typically less than 10 ppm. However, lead level in some cassiterite ores is higher because lead in cogenetic sulfides formed at the same time as the cassiterite with the same starting lead isotope ratios as the cassiterite. And so overall, it will drive the ratios down to where the cassiterite started before the uranium decay. However, foreign lead pickups with a different geological age from the tin mineralization, from smelting, for instance, will produce ratios not lying on the straight line isochron. When there are very high levels of lead contamination, it swamps the radiogenic lead from the cassiterite and tells you all about the lead contamination source rather than the tin source. However, luckily, many tin artifacts retain low levels of lead, and this allows us to use the slope of the line to indicate the geological age of tin deposit formation. This technique was developed by geologists and used by archaeologists on tin artifacts in southern Africa, Molensky in 2014. Berger et al. In 2019 used this approach to show that tin ingots from the Israel shipwrecks in the Mediterranean have a Variscan geological age consistent with all the main European sources, but they could not be certain from exactly which European source. Our new lead isotope data confirms the Variscan geological age, and we can see the line formed by our Cornwall Devon tin artifacts and the local Bigby Bay ingots all have the same slope as the Israel ingots. Also, the Roche Long ingots from the Mediterranean France also lie along that line. Let's just recap what we're trying to do here. Here's the tin deposits map again. The Israel tin ingots are Variscan in geological age. And so this eliminates most of the minor tin sources around the Mediterranean and many of the main Central Asian deposits as either too young, Turkey and Afghanistan, or too old, India and Egypt. The only tin deposits of Variscan age on this map are the Western European sources, with the advantage of being largely transportable by sea from Britain, for instance, and only the furthest most Central Asian deposits of the Tian Shan and the Altai Mountains, with the disadvantage of a vast overland distance to the Eastern Mediterranean, and no archaeological evidence for an overland tin trade route to the Mediterranean from these most distant of areas. The formation areas of tin deposits usually reflect the age of the geological orogenic zones in which they lie, as illustrated on this map after Powell et al. 2021. Our focus is on European sources, and we are trying to use the lead isotope technique to distinguish between two tin sources, Cornwall Devon and the Erzgebirge, within the broader Variscan geological age zone, because these two sources have indium analysis suggesting they're possible sources of the shipwreck ingots we've talked about. Recent isotope work on granites in these two areas in the geological literature shows there is a substantial geological age difference between these two areas of granite in Cornwall, Devon and the Erzgebirge of up to 55 million years. And this should be distinguishable by differences in the lead isotope slope of the associated tin ingots. Using IsoPlot-R geochronological software on our new data and pre-existing data in the literature on tin artifacts, excluding any samples with foreign lead contamination, we can predict more closely a geological formation age within the Verskyn period. The Cornwall, Devon and Erzgebirge tin artifact data predict dates that broadly match the published date range for the two granite regions. Crucially, these results show that the Israeli tin ingots have a mean predicted age, indicating Cornwall, Devon as the most likely European source, rather than the Erzgebirge. The predicted geological age of the Analoop Mollengat shipwreck Erzgebirge ingots match the Erzgebirge tin mineralization granite and help support this technique. Lastly, we come to the tin isotope results. The previous Mannheim project pioneered this technique and analyzed cassiterite from Cornwall to Central Asia. Unfortunately, they found major overlaps that limits their usefulness and then expanded their work to other types of analysis. Comparing our new data with existing data, we see that the tin metal artifacts have much less variation than the ores, as would be expected by the homogenization of tin smelting. Our smelting experiments suggest that in some cases, the amount of tin isotope fractionation may be much smaller than seen in the smelting experiments in Spain. Importantly, the Cornwall, Devon ore and metal tin isotope data range is fully consistent with all the Israel and Rochlom shipwrecks shown here. And now over to Ben.
So, our project set out to explore the provenance of tin, to try and provenance tin artifacts to tin ore sources. But this obviously leaves quite a few unanswered questions, not least, what is the scale of tin production in the Bronze Age? This is quite difficult to assess, possibly even more difficult than Alan's bit, I would argue. There are no Bronze Age tin mines in Europe, as Alan has highlighted. There are actually very few tin artifacts that survive. Tin oxidizes in a wide variety of environments, and so when you start totaling up the amount of Bronze Age tin objects or even early Iron Age tin objects, you're mostly stuck with a few shipwrecks off various coasts that you can see highlighted here, and a range of ornaments found in wetland contexts, such as in Swiss lake villages, and occasionally some nice beads that you can see in certain graves, but actually very small numbers indeed. Oh. There is another way that we can explore the scale of the tin trade, and that is by exploring the scale of Bronze Age copper production at very well-studied mines, such as the Great Orme, such as Mitterberg, several key individuals here, Kargali, and others. By the mid-second millennium BC, virtually the entirety of Europe, the Mediterranean, and into Central Asia are alloying copper with tin. If we are assuming that 90% of the copper output from these mines, the copper output from these mines must be matched with 90% copper and 10% tin, you can start to do some sort of rough estimates as to how much tin is required to match these copper mines. And so here we can see three mines ranging from small, medium and large, with Great Orme, Mitterberg and Kargali, that would have required around 25 tons of tin per year from all tin sources to match the 250 tons of copper that they were producing. There is a sanity check to my madness. Medieval Cornwall and Devon, using similar basic technology, record around 400 tons per year around 1200 AD. But a small proportion of this in the Bronze Age is not entirely unreasonable, especially when you consider in a recent article highlighting copper mines dated to the Bronze Age across Central and Western Europe that we now have 93 radiocarbon dated Bronze Age copper mines. This does not include all the copper mines that we have yet to find or yet to date. It does not include the Bronze Age copper mines in those copper-rich areas of the Balkans, Anatolia, Caucasus, Cyprus, Wadi Fanan and Timna, Eastern Egypt, etc. So we can start to think, I believe, of a tin trade in the Bronze Age that we can measure in tens of tons every single year being moved around to meet the copper output. When we start to explore this process of tin bronze adoption, full adoption, where the vast majority of the metalwork, in the case of Britain and Ireland, almost 100% of the metalwork changes from copper and arsenical copper to tin bronze, what we see is a process that happens early on, 2200 to 2100 BC in Britain and Ireland, and in subsequent centuries across Europe. It's worth highlighting that every region is slightly different. In Iberia, with incredibly rich tin sources, there is a very late adoption of tin bronze. In Central and in Northern Europe, there is quite a lot of use of arsenical copper alongside tin bronze for several centuries. Now, how did this actually happen? As you all know, the advent of metallurgy in Britain and Ireland is very late relative to continental Europe. It's certainly something that does not predate the beaker migrations as identified by our colleagues in ancient DNA and isotopes, and is something that would appear to be emanating from Atlantic connections. What we can see is expertise in identifying arsenic-rich copper ores coming up the Atlantic. Why do I say this? The earliest Bronze Age copper mine, or Copper Age copper mine, depending on how you want to date it, but the earliest copper mine in Britain and Ireland is at Ross Island copper mine. That is one of the very, very few places in the whole of Britain and Ireland where you can mine arsenic-rich copper. And they found it. How? I'm not entirely sure, but it means some quite exceptional prospection skills. But that is very much a technological transfer of arsenical copper mining and metallurgy up the Atlantic. It's worth highlighting that we are not seeing an equivalent shift in tin prospecting or tin bronze metallurgy either up the Atlantic or from Central Europe. Indeed, when you look at tin bronze artifacts, if I use the pointer, hopefully this will work. If you look at tin bronze artifacts with these red dots here, and these are your tin sources, there are very few in this area here indeed. And this is prior to the 2200 BC horizon of full tin bronze adoption. What we would argue is for a beaker-led discovery of tin ores and tin metallurgy in Britain and Ireland prior to 2200 BC. You've heard about the beaker site of Senon with the evidence of tin on the stone tools. As has been highlighted by many scholars, gold and tin occurred together in Cornwall. And as Chris Standish has demonstrated, a lot of the Irish gold, the early Irish gold, including the lunula, is actually not from Irish gold sources, but from sources in southwest England, likely in Cornwall. It's worth highlighting that with the beaker migration, what you have, even with the most opulent, rich burial of the Amesbury Archer, you do not have tin bronze, you have copper and you have gold. So therefore, beaker gold prospectors potentially rediscovering or discovering tin, and that then leading on to tin bronze adoption. The progression is incredibly rapid. What we see between 2200 BC and 2100 BC is a transition to daggers and axes, all daggers and all axes, going from copper or arsenical copper to full tin bronze. And at this time, not coincidentally, you also see the opening of the copper mines in northwest England and in Wales, which, with the exception of the Great Orme, are very low or have no arsenic whatsoever. I.e., if you wanted to alloy your metal to make it sufficiently hard to do the jobs that you want, a dagger and an axe, you would need to have tin. So we're assuming that tin from Cornwall and Devon is meeting the copper here to produce all of these daggers and axes. How then might we envisage the scenario here where you have the full tin bronze adoption across Northern and Central Europe? Sadly, there are no tin ingots from this early Bronze Age world that have been fully analysed so that we can compare them. There are some ornaments, but these do not have a full range of analytical data. So we have to start exploring possibilities of how the tin trade might have happened in other materials. In classic British archaeological scholarship, the first thing that you do is you start to look for the elite burials with the rich, exotic materials, exotic technologies of materials of very, very far away and distant connections. And here we see these burials famously around the area of Wessex in this area of megalithic constructions such as Stonehenge. Now, whilst these do have all sorts of elaborate metalwork and all sorts of exotic gear going on, we do not easily see any connection to the tin trade. And in fact, there's only one tin bead that's ever been discovered there, and that is now lost in antiquarian excavations. When we look in Cornwall and Devon, there is very little evidence at all for any of this Wessex richness that might be connected with the tin trade and might be connected with these distant connections. In fact, there's only two objects. The tin miners were not getting rich, in short. We have one, which is a now lost gold-studded dagger. So these are these famous daggers here with up to 20,000 sub-millimeter gold studs embedded into their hilts, as at Bush Barrow. But an important point to note, there's one at Bush Barrow, there's a lost one at Hambledon Down, but there are far more over the sea in Brittany and Armorica. When you start to compare what's going on in Wessex, in southern England, and what's going on in Brittany, the famous Armorican princely graves, it's very clear, as Stuart Pigger and many other scholars have highlighted, these are much larger graves with many, many more exotic connections and materials and technologies that span huge areas across Europe, and they are on a much grander scale. So if we assume that there is a tin trade coming out of Cornwall and Devon in the early Bronze Age, and I think it's fair to say that we can do that, even in the absence of a telling tin ingot, we would argue that it's much more likely the people over in Brittany, who are already very familiar with the tin in their region, have connections to Cornwall and Devon already back in the Neolithic, have a strong maritime and riverine connectivity tradition, and also have connections all over Central Europe. We would argue it is them who is actually moving and trading the tin and benefiting from it. Now, this full tin bronze adoption in Central and Northern Europe is definitely not going to be just about Cornish and Devonian tin. The exploitation of the Erzgebirge tin sources is undoubtedly playing a role. We have no idea exactly what the proportion of tin coming from Cornwall, Devon or the Erzgebirge is. Currently, the Cornwall, Devon exploitation is much earlier than the evidence that's coming out of Erzgebirge, but we really look forward to seeing the progress of the excellent Archeo-tin project. But worth bearing in mind that this change of full tin bronze daggers to full tin bronze axes is happening across Central and Northern Europe several centuries later than it is in Britain. And whether there is a stimulus there from Cornwall, Devon or not remains to be seen. And I also want to highlight there are connections, obviously, between these regions. And my favourite one remains the gold from the Nebra disc coming from the tin-rich Carnan Valley. There is only one other aspect of Wessex burial elite grave goods that you can find in southwest England, in Devon and in Cornwall. And these are these precious cups, which you can see dotted around the southern coast of Britain and across the near continental coast of Europe. These precious cups are in amber, in shale, in gold, in silver, and highlight early Bronze Age connectivity in what Stuart Needham has termed a maritory. Perhaps not coincidentally, they are dating to the same period as the earliest stone plank boats that you can see reconstructed here in Falmouth Harbour, the famous Ferriby boats. It's from here that I'm going to hand over to Alan to talk about the find from Southwest England.
Thank you. So, the Rillington Cup, gold cup. It was found in a barrow in a ceramic jar with human remains, a dagger, ivory and glass beads in the Minions area on the edge of Bodmin Moor in East Cornwall. The Minions is a tin-rich, multi-period landscape with abundant Bronze Age archaeology. The LiDAR, we have a complex multi-period landscape with these barrows, cairns, stone circles, standing stones, a hill fort, settlements, large numbers of roundhouses and field systems. The LiDAR image of the area reveals that the Bronze Age archaeology is surrounded by multi-period tin-rich landscape of alluvial workings and vein mines. We have annotated these features on this slide. Initial workings are likely to have started in the Bronze Age and then developed over the millennia right through to the famous ore-rich Phoenix tin copper mines of the 19th century AD. We come to the final phase of the full tin bronze adoption, circa 1600 to 1400 in red here, where there is likely to have been substantial increase in tin production and trade in southwest England. We are suggesting potential places in Cornwall and Devon where this might have been happening in this phase. One example is around Grimspond enclosure, high up on Dartmoor in Devon, thought to date from the later Bronze Age with massive walls and around 24 small roundhouses. Grimspond is situated 450 metres above sea level on the eastern flank of Dartmoor in Devon, controlling access to the eastern lowlands and connecting to tributaries of the River Dart, leading to the coast for possible trade. While it could be a cattle pound, as has been suggested in the past, it can be seen as a defendable enclosure, strategically situated adjacent to one of Dartmoor's richest tin ore landscapes, alluvial, and veins, with abundant evidence of Bronze Age settlement highlighted here in yellow. LiDAR reveals an extensive multi-period tin workings and represents a very rich resource that Bronze Age communities are likely to have been the first to exploit. We can superimpose Phil Newman's survey of multi-period tin workings. If any of these started out in as Bronze Age workings, they are likely to have been reworked on a larger scale in later periods. Finally, let's take a look at 3 multi-period sites in the wonderful prehistoric landscape of West Penwith in the far west of Cornwall on the Land's End Peninsula that may have had involvement in tin workings, storage or distribution. Tune Castle, Caer Bran and Castell Andinnes are Iron Age hill forts, but with some evidence of Bronze Age origins. All 3 have Romano-British settlement on their lower slopes. Several have tin-related finds, either tin metal or tin ore, as highlighted here. Let's just look at one of them. Caer Bran has Bronze Age ring cairns within the later Iron Age enclosure, and below is the Romano-British settlement of Carn Uni, in which fused tin was found in the Foggu. Using a LiDAR image, we can identify what tin resources the communities of these sites could have worked. Besides the tin veins, there is evidence of alluvial workings, both both on the LiDAR and as a sunken woodland feature on the ground. The rocky, hummocky ground produced by alluvial workings is often left as woodland in Cornwall. Overall, we need to integrate the study of tin resources in our Bronze Age and Iron Age studies rather than assuming that they are all medieval or later. And it's worth considering that thousands of tons of rock were moved in the large-scale excavations at the Bronze Age copper mines in Wales. And now back over to Ben.
Final phase, I promise, final few slides. Right. Tin is being exploited in southwest England, in Cornwall and Devon. Where is it going? We know that it is going to the Mediterranean through the analytical work. How is it getting there? There are some clues from shipwrecks. Thomas and I share a passion for shipwrecks. A maritime disaster is a bad thing for the people on the boat. It's great for archaeologists. And what we see with the Salcombe shipwreck and with the Langdon Bay shipwreck is a distribution of artifacts found on the shipwreck that takes you down the French rivers. Here you see in this map the famous Sicilian strumento, found only in the areas around Sicily, as well as several other objects found down the French rivers originating in the central Mediterranean. This is the distribution of all the types of bronzes found on a shipwreck off the coast of Dover, again, taking you down the French rivers. But geographically, you cannot go from north to south of France with just one river. You have to cross the land. You also would be crossing into a very different cultural zone at around 1300 BC, which is our period in question, both for the shipwrecks I'm talking about, but also for the tin that we've been provenancing from Cornwall, Devon, going down to the coast of Israel. And this indicates that you may well have upper zones, as highlighted by Claude Mondon and others. So where you are crossing into a new cultural area, or alternatively, where you are actually having to carry your cargo over the land. You are having to do this in an area where you need safe passage. You don't want people to just kill you or your family every year or try to kill you every year you try and bring tin down there. So you need safe passage, but there's always going to be some sort of price for that. And what we see from 1300 BC is an explosion in this area here, into there, of opulent graves, large settlements, and fantastically exotic grave goods. It's hard not to connect this to potential trade networks down the French rivers. Another indication of this going on is the multiple finds of different types of weighing technology in this Yon region. The ability to actually weigh and measure goods down to as little as maybe 90 grams, or even lower than that, is something that we have spreading across Western Eurasia at this particular time. And certainly something that ties in to the many other goods as well as tin that are being moved along these routes. It's certainly no coincidence that along with this trade, along with this movement, you are also having the transmission of new weapon technology. So this sword here, found on the coast of Salcombe, on the Salcombe shipwreck, is one of the earliest types of swords found in Britain and Ireland, a hook-tang type sword, and here with a distribution map from Stephen Matthews of other similar swords, whose distribution takes you down the French rivers to the central Mediterranean region. There's even weaponry that is coming up the other way. The much debated hook-tang Cypriot daggers, as the name suggests, from Cyprus, are now found in distributions going up the French rivers and across into Britain, with a particularly large hoard found in southwest England. Once the tin reached the central Mediterranean, it is likely to have been moved by networks that formed in the mid-2nd millennium BC, around 1500 BC, spanning Sardinia and Cyprus. We can see this evidenced in work by scholars such as Serena Sabatini and Fulvio Laschiavo, whether it is in copper oxide ingots, metal types, or in the spread of Sardinian pottery to the East Mediterranean. There's a lively debate here that I can't get into amongst Mediterranean scholars as to the nature of all these interactions and trading networks, but even skeptics such as Bernard Knapp happily agree that there is an overlapping set of regional interaction spheres along which goods were being moved on a very regular basis. So what we have here is not a direct link between Cornwall and Devon and the coast of Israel. It is actually very much a down-the-line series of trades that have taken a long time between different centres in a trading network. It is notable that on the shipwrecks that we've been talking about the tin provenance from, the lead on several of them is provenance to Sardinia. It is also notable that some of the tin ingots have Scipio-Minoan inscriptions on them, despite the fact that they originally came from Cornwall and Devon. What we're seeing here is the elements of a multi-stage down-the-line Bronze Age trade network. Now, is this so surprising at 1300 BC? I'm going to argue not. I'm going to argue quite happily that tons of tin could be moved along this route 1300 BC because there's plenty of other things that are also moving around at the same time. So I am married to the specialist who studies shields, detailed here, so I'm obligated to produce a shield slide in almost everything I do. And it's been highlighted by my lovely wife that the Hertzsprung symbol on the shields that she studies at Fuslinde and elsewhere can be found in different media, whether that is in stone, whether that is in bronze, whether that is in wood, across Iberia, across Ireland, and across southern Scandinavia, and recently dating by Barry Malloy places them only a century or so later down in the Aegean. So this is one element of this interconnected world, but there's plenty of others. A much debated recent paper highlighted the spread of the second phase, the Dom-2 domesticated horse in the second millennium BC from the Eurasian steppe across Europe. So by the mid to late second millennium BC, we are seeing horses, very, very different kind of evidence, but very much an interconnected world. Not coincidentally, the much debated world of chariots, slightly different dates, but again, what we're seeing is the rise of this very interconnected world that we are seeing over land and land transport, not unrelated, of course, to the horses. We can turn to our friends who are studying plants and archaeobotany. It's worth highlighting that millet domesticated in East Asia is now being actively grown in the mid to late second millennium BC across Central and Northern Europe. None of these are implicitly connected to the tin trade itself, but they're very much part of an interconnected world in which trade goods, materials, technologies, ideas, and people are moving. And we can see that when we study glass, when we study crops, when we study sword and sheet metalwork technologies, when we study gold, when we study land transport technologies. We can see this multi-stage route along which tons of tin could be quite easily moved, as so much else is also being moved. Now, what are our conclusions? Firstly, a beaker-led discovery of tin ores and tin metallurgy in Britain and Ireland prior to 2200 BC, leading to full tin bronze around 2100 BC, centuries ahead of Western Europe, and subsequently being a major tin source for the bronzization of Europe. The growing archaeological evidence for small-scale but widespread Bronze Age tin production from abundant and accessible alluvial deposits in the tin-rich valleys of Cornwall and Devon. As Alan highlighted, we envisage a decentralized production model. Don't have evidence of central control for production, with agriculture still dominant, but with numerous small workings in the slack period of the agricultural year, taken to a central ictus-type trading place, possibly via storage and distribution sites. And that is where the control comes in. I would favour that the Cornish and Devonian tin producers are not the ones necessarily doing the tin trading. This is being done down the French rivers by those communities there who are then passing on to Mediterranean traders. It's worth recapping. For the first time, British tin ores and tin artifacts have been extensively analysed with 3 independent techniques, found to have ranges fully consistent with tin ingots from 3 Bronze Age shipwrecks along the coast of Israel: Shuli Carmel, Kfir near South, and near Haifa, all dating to the 14th to 13th century BC. Chemical and isotopic results of these ingots are very, very similar indeed to the Sulcan and ingots. The projects identified the most likely European source of the ingots found on these 3 shipwrecks. Indian has eliminated Iberian, Brittany, and Massif Central ores. Geological aids determined from lead isotope data indicates that Cornwall Devon is the most likely tin source rather than the German Czech excavator. Crucially, our data shows that Cornwall Devon could also be a potential source for other Bronze Age to early Iron Age tin ingots in the Mediterranean, including on the Uluburun shipwreck, Turkey. This project, we feel, provides evidence for a potentially extensive pan-European tin metal trade, stretching during the mid-2nd millennium BC from southwest England into the East Mediterranean, alongside other indications of long-distance connectivity. And I'd like to highlight, finishing the example, that the confidence of the people who were actually producing the tin in Britain was such that they actually imported their copper. They decided not to get any copper from Britain anymore. They would quite happily rely on the imports from the economy that was clearly developing and thriving at that time. This is just one example of the many different examples we have of this long-distance connectivity. This project was only possible from a fantastic core team that you see highlighted here, as well as a vast array of contributors and collaborators to our project. We're extremely grateful, and we consider this to be merely a stepping stone towards even greater projects and debates surrounding the world of ancient tin. Thank you for listening.